Hello all and welcome back. So in this video, let us now continue our discussion on binary trees, and now let's see how can we print our binary tree. So while we are printing the binary tree, the basic idea is going to be the same. Let me just draw a binary tree which we made in the last class. So we created a binary tree which were having a 3 nodes, right? So it will be better if instead of just using some tool, or let's say where we cannot use any tool, we are able to print our binary tree as well. So this was the overall binary tree which we created, everyone. In this tree, we see that we have 3 nodes, right? Now, what I want to do is to again make sure that I am able to print out these nodes in a way that it tells me the complete binary tree structure. Okay, great. So let us try to print this, everyone, now. So let me write a def print tree binary tree where we will be getting a root. Okay, great. So the very first thing, we can just print the root dot data. Okay, as with generic trees, our overall idea, our overall approach is going to be the same. That because each and every one is a binary tree in itself, so each and every of this node is a binary subtree in itself. I can very well use recursion, right? So let me write that as well. Recursion can be used. Okay, so recursion can be used as each node is a binary subtree. Okay, or a sub-binary tree, rather that would be better because nothing like binary subtree. Great. So is a sub-binary tree. Great, everyone. So yeah, let us just use this understanding. So what effectively I'm saying is that this is a tree which I can take like this. This is also a tree which I can assume like this. Okay. So yeah, let us call on these subtrees and our work is over. So print root dot left, print root dot right. Okay, great. So let us run this, everyone, and see if we will be able to see the result or not. I'm passing the root, so we know the structure, just the one which I drew, and let me run this now. So root dot left, it is printing the data, which is root and sorry, my bad. So we should have done not print, but we could have used recursion, right? We could have used recursion. Okay, so it seems that I'm getting an error. The error is that none type object has no attribute data. Okay, so something like this error we have seen before, right? Whenever we are trying to call this root on none, then we used to get this error in linked list as well as in trees. Now, in the generic trees, if we are not passing none, then why are we getting this particular error? Well, the reason for that is, so let us understand this, everyone. I want each and every one of you understand this as well. If your node is none, okay, then we should return. Not node, it should be root. Now, here this is a base case. Here this is a base case. The reason is that in the earlier implementation, I was writing a loop. The loop was going to each and every node. Okay. But this time, I am actually calling on the left and right specifically. Okay. So just to make it a little bit more clear, what exactly will happen? I have this node 1. It is going to get printed. It is going to give me 2. It has left and right as 2 and 3. Now what I'm doing is when I come to 2, I will be printing 2. So I will be getting the output as 1, then 2. But after that, I'm making the call irrespective if 2 has children or not. Okay. So either we can restrict the call by checking, okay, if the root is none or not. Okay, if the root dot left is none or root dot right is none. Or we can just use this particular as our base case this time, because it's going to get hit. It is going to see that, hey, none is here, and it's going to return. So this is what this return will do. Okay, everyone. And that was the reason we were able to see 1 and 2. So let me just comment this. We were able to first see 1 and 2, and then the error was coming because it is trying to get the data for 2's left, which is none. So none dot data is coming here. Okay, great. So let me uncomment this. And now if we run this, we are able to see. Okay, just one problem, the same problem which we had in this pre-order kind of a traversal, that if it is 1, 2 and 3 the way I'm seeing, it can even mean a tree like this. It can very well mean that a tree is like this. It can very well mean that a tree is something like this as well. Okay. So again, I need to have that distinction. So for that, just we are going to add some beautification to our overall output. So let us do that, everyone. The very first thing which we can do is we are getting this thing, right? So we can print the root data. Okay. And let's say we are ending it with a space. So in the end, I don't want a new line. I just want to print it with the root data. Now what I'm going to do, so the way I want to output is, which I think will be a lot better, is something like this. So I want to see 1. Okay. Then I want to see the left of 1, something like this maybe, and the right of 1. Now this time, just printing out the data will not work. Okay, because my left and right are different. That is the reason I'm making sure that I explain you this in this much depth, so that you never make a mistake here. So left and right. Then I will print out 2. 2 has left, which is as none, and right, which is again as none. Similarly for 3, left, none, right, none. Okay, everyone. So this is the way I want to print out my overall output of the tree. So let us write the code for this. We just have to make sure that we are able to print it nicely. We have printed this information. Just have to make it a lot more beautified. If my node dot left is not none, what I have to do? I have to print. If it is not none, then I have to just call my I have to print this particular data. Okay, recursion will be called afterwards. So the way I can print it is something like this using the formatting L, and now I can use node dot left dot data. Okay, reason is again the same. I am able to use it because it says that it is not none. Else, if it is none, then I have to print L none, and we can end it with this as well. So great. As of now, it seems to work fine, and it is not root. My bad. Sorry, not node. We should be using this root everywhere. Okay, everyone. So I will just explain till now what we have done. Along with printing the root data, in the generate tree, we were running a loop for all my children. Here, I know that I have just left and right to handle. So using that knowledge, I am just trying to basically make 2 conditions instead. Because again, this logic now have become a lot more easier for me, right? I don't have to work on number of children, write any for loop. I know that 2 children are there, and thus I can make the overall tree structure a lot better printable, right? On the same note, if I can just copy this, then what we can do is we can just check if root dot right, and let us make it r, let us make it r, and let us make it right. Okay. So again, just I have added these lines. After that, we are just recurring for the left and right children. So recur for the left and right children. Okay. And let me write the format as well, so everyone is clear that what exactly is happening. So my format is going to be something like this. Format node left child data are right child data. Okay, everyone. So I think, yeah, this is going to do. Just one thing, we should remove it here. Okay, because we don't need this. In the right, we don't need this particular thing. Great. So yeah, let us try to run this now, everyone. Pretty straightforward code. And I'm able to see now my overall data is in a lot better format, right? So I'm able to see that left 2, right 3. Then for 2, left is none and it is right is none. Just one thing to add here, what I can do is in this, I can just end it with this, right? So yeah, great. Now I think it is a lot better in terms of everything. So we are getting 1, the children are left, 2, right 3, 2, left none, right none, and 3, both are none. Okay. Again, easy overall tree which we have visualized, right? To make sure that we are able to actually see, I have in a similar manner created some predefined decision trees, just like we created in our generic trees. So they are the binary trees, everyone. They are the binary trees which are having this structure. So let us use this code and try to run it for root 1 just. Okay. So I'm just getting this. So from predefined import, predefined binary inputs. Again, if you're not aware, please make sure that you see the last module. These are just trees in a similar manner I have defined so that we can use the same. It is just visualized here and something which we can actually use directly. The reason is same. We don't want to create these trees one by one ourselves, right? This is a lot time taking process. Now, if I just call print binary tree on root 1 and if I run it, let us see if we will be able to draw our tree rightly from this. So that thing is very important again, everyone. Okay, let me run this again so that the first one gets out. Cool. So from this understanding, if we are able to draw our tree right, then I think we should be good. So I'm saying that, hey, 1 is there. 1 has left as 2, right as 3. 2, 3. Then we have 2. Left is 4. Right is 5. Great. 4. Left none, right none. 5 also, both are none. 3, it is saying that left is none and right is 6. So I can take this right as 6. And 6 also, both are none. Okay, everyone. So this is the tree which I am getting. Let us just see this quickly. If this was the same, 1, 2. Yeah, seems like we have created a right tree. The overall printing is also working pretty good. Cool, everyone. So yeah, I hope this is clear now. Just make sure that you have an idea that why this left and right is getting used. Although overall, I think that this code and the idea which we are spending on this binary tree, that is a lot clear. Okay, thank you.